Welcome. This video is for Chapter 2, Review Number 2. This is answers to the quiz that you took in class. Feel free to watch as many of these 8 questions as you need. Feel free to just skip to the ones you got wrong or listen to my explanations on all 8. We have a test coming up on probability. A jar contains 4 white chips, 5 purple chips, and 1 black chip. So when we get a list of things that are all in a box or a jar or a bag, I would get the total. Okay, there's 10 total chips in the jar. We're going to select them one at a time, and we are not going to replace. So that's a big deal. Okay, that means that this problem is called dependent. The first fraction does something, and the second fraction depends on what happened first. Find the probability of the following. Write your answer as a percent, round to the nearest tenth. So the probability of the first one is purple and then black. That's the amount of purples out of 10, which is 5 out of 10, times our second fraction has to change. We want the second fraction to be black. There's only 9 chips left in the jar since I took a purple one out. So this is going to be 1 out of 9 since we have only 1 black chip in the jar. One thing that you might do with this is reduce fractions. So 5 out of 10 is just 1/2. So we have a total of 1 times 1 on the top, 2 times 9, or 18 on the bottom. Since they wanted 0.1%, I'm going to keep going. This is 0.05, and it's 5 repeating. So I always round that third digit either up or down. So this, as a 0.1%, would be 5.6%. If you type it in on Schoology with a percent sign, make sure you type in the percent sign. Okay? Second one, black then white. So out of 10, there's 1 black to begin with. We want the second one to be white. There's only 9 chips left, and there's 4 of them that are white. Okay? This, you can reduce the 4 with the 10 if you want. So I could divide this by 2 and divide this by 2. And what I end up with is 1 times 2 on the top, which is 2, 45 on the bottom. Okay, as a fraction, but as a decimal, it's 0.04 repeating, so 4, which is, if we're following directions, answering as a 0.1%, that would be 4.4%. Okay, purple then white. Okay, purple then white. Out of 10, there are 5 purples, then there's only 9 left, and 4 of them are going to be white. Okay, again, you can reduce this down to 1/2 if you want. Okay, and then you can also take this 4 and divide it by 2, and take this 2 and turn it into a 1. So up top, we have 1 times 2. On the bottom, we have 1 times 9. So this is 2 out of 9, which is 0.222. Which is 22.2%. Okay. I think on Schoology I did let you type in the fractions if you wanted. Last one, white, then purple, then black. Out of 10, there are 4 white chips. There's only 9 chips left. 5 of them are still purple. Now there's only 8 chips left, and 1 of them is black. Okay. So when you do this one, we get a total of 20 along the top, 4 times 5 times 1. On the bottom, 10 times 9 times 8, that's 720. So that's if I don't reduce and just multiply across. That reduces all the way down to 1/36. As a decimal, that's 0.028. We have 27777, so that's going to round up to 2.8, which is 2.8%. Like I said, I think on Schoology you can type it in as a fraction or a decimal. If you do the percent, you have to do the percent sign. Number 2, a bag contains 6 red marbles, 7 white marbles, and 6 blue. That's a total of 19 marbles. We want the probability that it's red or blue. Okay, or means add. So this is called a mutually exclusive problem because we can get a red, we can get a blue, but we can't get a red and a blue. So this is just the probability of red plus the probability of blue. Okay? So that's going to equal 6 out of 19 plus there's also 6 blue. Oops, out of 19. My fault. So up top, we get 6 plus 6, which is 12. Remember, don't change the denominator when you add those fractions. 12 out of 19 is perfectly fine since that's reduced. Number 3 is a trick question. We're only getting one marble. Okay, same exact setup. There's going to be 19 total. The probability that we get one that is red and blue is something out of 19. Okay, this is why this one's a little bit of a trick question. Okay, if there was more than one marble we were taking, we would do a one fraction for every marble we're getting. We're only getting one marble. Some of them are red, some of them are blue, but 0 of them are both red and blue. None of them will be both colors at the same time. So this is just 0%. It's impossible to take out one marble that's both colors. Number 4, there are 3 literature books, 4 algebra books, and 2 biology books on a shelf. Okay, that's going to give us a total of 9. If a book is randomly selected, one book, what is the probability of selecting a literature book or an algebra book? So this is an adding problem. Find the probability and record your answer as a percent rounded to the nearest 10. This is also called mutually exclusive. There's nothing to subtract this time because you can get a literature book or you can get an algebra book, but you can't get a book that's both. So you don't need to subtract anything. This is the number of literature books out of 9 plus the number of algebra books out of 9, which is 7 over 9. As a decimal, that's 0.7 repeating. So when we round to that third digit, we would round the third digit up to an 8, since the fourth digit would be a bigger than 5. So 77.8% is our answer rounded to the nearest 10th. If you typed it in like that, make sure you type in the percent sign. Okay. Number 5, a basketball player makes 85% of their free throws. What is the probability they'll make the next 3 free throws they take? Okay, so the probability that they make the next 3, okay, it's the probability that we make the first one, which is 85%, 0.85, times the probability we make the second one, which is 0.85, times the probability we make the third one, which is 0.85. We call this an independent problem because the first free throw won't impact the second free throw or the third. Every one I have an 85% chance of making. So when you do 0.85 times 0.85 times 0.85, you get 0.61, and then rounding it to the third digit, we get a 4, which is 61.4%. Okay. If it would have said the next 5 free throws, we would have had 5 85s, and so on and so forth. Okay. Second page. This is a spinner used in a board game. What is the probability the spinner will land on a multiple of 3 and 4? So it wants to land on both. So this is, even though it says and, not a multiplying problem. Okay. We want the probability that we land on something that's both. Okay. Multiple of 3 and 4. Okay. Well, it's how many spaces there are, which is 8. On the top, we're going to look at how many are multiples of 3 and 4. So some of them are multiples of 3 in here, some of them are multiples of 4, some of them are both, some of them are neither. This number right here is a multiple of 3 and 4. Okay? 3 goes into 12 and 4 goes into 12. Same with 36. 36 divided by 4 is 9. 36 divided by 3 is 12. Okay, so those two both work. 24 is a multiple of both. 24 is a multiple of 3, and it's a multiple of 4. And that should be it. All the other ones are not both. Maybe some of them are multiples of 3, but not 4. Some of them are multiples of 4, but not 3. Some of those are not multiples of either. So there's a grand total of 3 spaces on that spinner that have a multiple of 3 and 4. Suppose you are dealt 2 cards. What is the probability that both cards are diamonds? So this is saying assume no replacement, which means that this is called a dependent problem. the second fraction depends on the first fraction. Okay? So the probability that we get 2 diamonds, so diamond and then another diamond. Okay, the first one being a diamond, there's 52 cards in a deck, and there's 13 diamonds. There's 13 of each suit. The second one, so and means times, the second one, there's only 51 cards left, and there's only 12 diamonds left. I took one of the diamonds out of the deck, so there's only 12 left, and there's only 51 total cards left. If you punch that in, you get 0.05, and then I get 8, so I'm going to round the 8 up to a 9. So this is 5.9%. That's your probability that both of your cards are the same suit, which is diamond. They're both diamonds. Okay, last one. In a 5-question true or false quiz, what is the probability that true is the correct answer for all 5 questions? Okay, so that would be true, 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 true. There's only one way to do that. Okay, there's only one way to get true, 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 true. The only answer key that exists where they're all true. The bottom of the fraction, okay, so the top is going to be 1. The bottom of the fraction, you have to think about this. Each of these is 2 choices. We have 5 questions that are 2 choices each. So that would be 2 times 2 times 2 times 2 times 2. There's 5 questions. Each question has the possibility of being either true or false. There's 32 ways to make an answer key with 5 true or false questions. So we have the top, we have the bottom, we can do the answer. The probability that it's true, 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 true is one way to do that out of 32 possible ways. That's it for this video. Feel free to watch them again. Feel free to ask me questions on things that you'd like me to clarify. Thanks for watching.